video explains it. It's a molecular fusion. It's like one of the guys explains it as a plastic welding plastic. So same as a welding activity. Those two metals, two similar materials weld together. So what happens here, this is going to come down, and then we're going to break away, and I'm going to show you what's happening underneath that head. And what I want to do today is demonstrate what happens under a hot stamp machine between your product, and this plaque is going to represent your product for this demonstration, and our label here. Both of these products start with a raw olefin polymer material, resin, and that's the same as this. This is how our labels start out, and then they're mixed in a matrix to make them into a liquid state so they can be dispersed onto a film. And in this example today, you're going to see the white here. That's pretty much what this is. And this substrate are basically the same material. They are exactly the same, and they're compatible. That's how the fusion technology in our label is able to work. So these two actually integrate together under the head during hot stamp activity, and I'm going to show that today. For lab purposes, let's pretend like this is underneath the head of the hot stamp machine and the die. So what you have is your product comes through, the label comes through, they start to melt, and we're talking millimeters of thickness start to melt on your surface just like this. The label technology melts at the same rate as the product does, and you end up with a one integrated fused technology. And you can see how this technology, how this fusion occurs. This is actually the same, and it has the same stretch rate, the same expansion rate as the material, because it's one material. It's not sitting on the surface. This is integrated. It's fused into there. You can see that. Hopefully the camera's getting a good shot of that. Look at that. It's plastic, basically welded to plastic. So I'm trying to get underneath there for you and show you that. Look at that. So you can look at this, how that technology just fuses. Remember, these are compatible materials. So if we talk about other label technologies such as bonded or adhesion base, they would sit on the surface of this of your product. They wouldn't integrate in there, or they would not fuse in there. They would sit right on the surface, and they can be taken off later and under deterioration and normal environmental exposure. See, you can see that now. This is starting to get up to temperature, and you can actually see these two becoming one. You can see it's not surface. It is actually fused right into that product. So you can take across. Let me hold on to my plaque. Let's say we come across here. That's a great example. Look at that. Look how it just stretches with that plastic. Pretty crazy. You'll see no other technology in the world like this. Look how see how that's, there you go. Look how that's just very elastomer sitting on, integrated in there. There you go. It's one piece of plastic. There's not two pieces of plastic here. This is one. Okay, we've let our test sample cool down. So what I want to do now is I want to show you, look at this. Look at what's really kind of cool about that. Look at that fusion. Look at that integration. Maybe you can do a close-up of that, blow that up a little bit. Look at the integration. Look at that. That is one piece of plastic. It's hard as a rock. That is fused, integrated into your product. So what I want to do now, if I can get this to work on here, is I want to do a ASTM 3559 tape test for you to show you that this is truly fused into there. So and I'm pushing hard, folks. These are razor blades here. Now you can see the cuts in there, and this is standard tape you'd use for that test. I'm going to come across here. I want you to see that I'm putting some good pressure on there. Look at my fingers. No. Okay. Then we're going to pull this off of here, and look at that. Zero removal. Look at that. Nothing came off of there. Not even any surface. It's integrated into that. There is one piece of plastic there, and hopefully, like he said, he showed you some of these blown up. But here, we'll get another piece of tape here. I'll even do some more cuts for you. Let's try and do one up here on this piece here, and I'm pushing. Let's slice that thing up really good for you. Show you that there is that thing is fused in there. Look at that. Look at those cuts in there. Any normal bond label, technology or adhesion label, that'd peel right off. Wouldn't be able to withstand that. So let's cut a new piece of tape here. All right, let's go across this piece here. That's what, if you were doing a label or something, or an adhesion type label or something, this is where you would have a failure mode. This would peel off. But because this is integrated or fused into your product, it can't come off because it's part of your product. It is your product. There you go. Look at that. Zero removal. That thing is integrated in there. So with that said, this technology is pretty incredible, and it's the word, when we talk about permeability, this is true permeability. A lot of other products out there, technologies claim permeability, but this is your true permanent fused integrated label technology. Okay, now that we've looked at what happens on the hot stamp machine under the die head, let's look at this from a molecular level. So what we've done is we've taken a substrate with a fusion label applied to it. We sent it out to a lab, and we had it cross-sectioned, and we've done some SEM analysis. That's a scanning electron microscope. It can look at very finite detail, and we're going to demonstrate that here in a minute. I'm going to show you some slides on that. So what I want to talk about right now is what you see in front of you. You'll notice up here at the top, this represents the label, this represents your product. So you see how they molecular fuse together during the melt process. So remember earlier I talked about how they're like material, and they have the same melting point because they're both olefin materials. So with that said, let's look at SEM. So what you're going to see here, this is 20 magnification. This is basically taking a high level photograph. And what you're going to see is very non-linear surface here. This area up here, this is the epoxy they have to mount the substrate and label in. All this area up here is not important to us. What's important is this surface here and this surface here. So you'll notice how you'll see some of the substrate actually in the olefin material up here. This is the actual label, the color that you display on your product. So you can see integration down in here. But let's blow this up now. Let's see what this looks like at a higher magnification. So this is 50 magnification. Again, it's just a high level camera, and we'll look at this. See how this substrate, this is your product substrate, it's up into the pigment. It's up into the olefin label. And you'll notice down here, this is a non-linear surface. And what I mean by that is that I'm going to demonstrate that in a little bit. Linear, there would be a definite layer here and a definite layer here, but there's not, because this is actually integrated together. You can see the olefin from the substrate up into the olefin of the label. Look at that. Look how this is really integrated in here. So this is why this becomes one plastic that I described before, and it cannot be separated as could if it was a technology from an adhesive or bond. here's 50x now. So you look at this again, look at this, look at that integration. This is all of your product that's integrated. It's actually fused together. They become one material. And as I'm going to demonstrate in a minute, if you look at a label or a hot stamp or any other type of technology, there's going to be a straight line here, and that line is going to represent two different unlike materials. And as I've been defining here, these are like materials. Remember, this is the epoxy, so this isn't important to us. This surface here isn't important to us, but this is. This is your product, and this is the label married together, fused or integrated. So now here's where we actually get into the actual SEM image. Look at this, very nonlinear. They are married together. You can see how they've fused or integrated together. All that polyolefin from the label and the substrate have now mixed and become one. So this is what makes this technology so awesome, and what makes it true permanent too. Makes it very durable. And the only way you can get this off is to scrape away your product, and that's the only way you can get into this. So because basically your new product surface is now here because this label's integrated part of that. So let's look at different technologies now. So we also had an IML cross section. We had a hot stamp foil and a PSA. And remember, previously I've talked about linear surface. Look how linear this is. Now your hot stamp foil, it's not quite as linear, and there is some integration here, but it's still a surface type bond. And if you look over here, these are adhesion, and then you got your label, and then you got other types of, maybe this is your cover. These are dislike materials. They're not going to stick together. So anyway, this should give you a pretty good explanation now of how the fusion technology works. And hopefully these SEM analysis really gave you a deep insight to what's really going on at the molecular level.